Hey everyone! Okay, so today is a little bit of a wonky day. I think I have officially overworked my computer. It said, absolutely no way, Jose, you cannot have two screens today. So today, I unfortunately won't be able to see the comments. I know, how dare I? But I will be more than happy if you post any questions into the Facebook group or if you go to the replay. If you tag me, my name is Indira Pryia on the Learning Liaisons page. So if you look for me and you just tag me, I will be more than happy to answer your questions. So today looks like I might just kind of be like doing this blindly. I know, kind of crazy for a Wednesday, but happy Wednesday, everybody. As always, my name is Pryia. I hope these notifications are not bothering you, but this is what we're going to do today. I'm going forward. Here we go. I did have a question to please help with more probability and statistics. And I love when you guys ask me for specific questions because I love helping you, right? So here we go. Today is a lot of probability and statistics, and I think I have one question at the end that's not. All right, so let's get started. Question one is brought to you by, what did I say? Probability and statistics. It is one of these simpler problems, right? This is not the as so intricate kind of problems that we can see in probability and statistics. And the thing about that is it doesn't fall short of, you want to make sure that you know how to still do this, right? So here we can see that we have three coins, and these three coins are tossed into the air, and they're all tossed at the same time, right? So if we had to draw a picture, this would be me tossing my coins. Here's my lovely hair. Coin one, coin two, coin three, right? I toss them up into the air, and then when they fall on the floor, they want to know something very specific. The question asks, what is the probability that two of those coins will land on heads and one will land on tails? Well, if we think about a coin, any coin, to be honest with you, there's only two sides to the coin, right? There is the head side and there is the tail side. And I know that sometimes you guys have different countries have different coins, things like that, but we're just talking about the American coins here, a plain Jane regular coin. And let me tell you, just in case you were wondering, it will not, and I promise, not ever land on its side. That is one guarantee that I can give to you, that you do not have to now worry about ever again. So the coin will only land on tails or heads, and it can't land on both if it's one coin, right? So when we see questions like this, things start coming to our mind and we start asking ourselves, like, how do we solve this, right? I'm not going to put three fractions here like I've taught many of you in the past to do, because here it's very specific. Here we need to know the actual combinations to what the outcomes would be. Why do we need to know that? Well, we have to know that in order to be able to accurately answer the question, right? So what will happen? So we have to actually make those combinations. So what will happen here is we can have a heads, heads, heads situation, right? Then we can have a heads, tail, heads situation. Then we can have a heads, tails, tails situation. We can have a heads, heads, tails situation. And those are all the heads first situations that we can have. Now we move on to the tails first, and we can have a tails, tails, tails situation, a tails, tails, head situation, tails, head, tails situation, and a tails, head, head situation. Right? And some of you may say, oh, but what's the difference between the heads, heads, tails, and the tails, heads, heads? Well, in this case, it matters. Why? Because we have coin one, coin two, coin three. Right? And each time coin one lands, it's going to be different from coin two and coin three. So even though these two may seem the same, they actually aren't, because coin one in the first box is a heads and coin one in the second box is a tails. So we have changed the outcomes, right? So now we're looking at it and we're going, okay, well, what do I do from here? You just go back and see what they're asking you for. They're asking you that two of them land on heads and one will land on tails. So we're looking for anything with two heads that looks like this guy over here, this guy here, this guy here. Oh, and that's it. We only have three of them. We're still going to do our normal fraction here, which tells us the part that we're looking for over the total. So we'll have how many in total? 1, 2, 3, 4, 5, 6, 7, 8. So we'll still have a total of 8. And the part that we're looking for is 2 heads with 1 tails. So we'll have 3. 3 out of 8. Winner, winner, chicken dinner. Okay, so the thing about the 3 over 8 is give me 1 second. Okay, now I'm like sharing everything. Haha. Let's see. Okay, so you guys can't see anything. So I've been like talking to myself this whole time, right? Yeah. Okay, hold on. Let's try this. Ooh. Okay. I think I'm going to take my computer off. Give me 1 second. I can see all of you guys. I know. I'm still here, I promise. Let me do it this way. I know, my computer just said no more. You're done. Like, please stop using me. We're tired. Okay, so now can you guys please tell me if you can. Okay, give me 1 second. Maybe that didn't work like I thought it was going to. One more second. I promise I'm coming back. I'm still here. I can hear you. Well, I can't hear anybody. Okay. Okay, here we go. The unthinkable. I am going to tell my computer to do more than one thing at the same time. And it should work. Give it 1 second. I'm still here, I promise. I know I'm just gonna keep talking to you until I can get my computer to do it one more time. Okay. I know, I promise. I'm still here. Wham bam, thank you, ma'am. I got it. Okay, somebody, please, anybody, tell me that you can see this. I know we're like 9 minutes into this and Pryya's still figuring it all out. Woohoo! Okay, so I assume you guys saw absolutely nothing. So we're going to start back from the beginning of this really quick. I know, how dare I? Old computer. Promise, I'm updating soon. Anybody want to gift a computer? Just kidding. Okay, so here's the pencil. We had to write out the combinations, right? So this is something that we just had to figure out. Some of the questions are easy because we're pulling things out from drawers, we're pulling things out from bags, we're pulling things out from other things. But in this situation, we actually have to do the work. So I created all of our possibilities, right? So I created heads, 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 and we can land on all 3 tails. We can also have a heads, tail, head situation, heads, tails, tails, head, head, tails, right? And then we can go on to explain the rest of it. But one good thing that we want to keep in mind is when we're making these combinations, because sometimes you guys are going to go, but no, there's no way I'm going to sit on my test and I'm going to do this because there's no way that I can do this. You can totally do this, right? You just have to take your time and figure out if the combinations are finished, right? So what I did was I started with heads and I said, well, what can I make from there? And we did heads, heads, heads. Then I said, all right, well, if I change the middle one, it can be tails. So now I can have heads, tails, heads. And I can do tails at the end of the heads, tails, heads. But now I've exhausted all of the middle being tails, and now I created my last one in that column to be heads, heads, tails. right? So we can really do all of this. You just have to believe in yourself and just take your time to make the combinations, right? So when we put out the combinations that we have a total of 8 of them. Well, how do you know, Priya, that you have 8 of them and you don't have more? Well, I've exhausted all of the heads and I've exhausted all of the tails, and there's nothing else to work with. There's only heads or tails. So I went ahead and said, all right, it is time to do the problem. So the problem tells us that we need to figure out how many heads, 2 heads and 1 tails there are. So I said, well, first let's count how many in total there are, and that's how we have 8, 7, 8, boom, total 8. Then we did how many heads, how many 2 heads and 1 tails do we have? And that gave us 1, 2, 3. 3 at the top, 3 out of 8. Now here's the lovely thing about 3 out of 8. Sometimes you get 3 out of 8 as your answer, but that's not your answer choice, right? So we want to go back and say, well, if 3 out of 8 isn't on there, I can take a fraction and change it into a what? I can see the comments now, so you guys can comment. A decimal. Okay, so now I'm going to take my fraction, turn it into a decimal. So 3 divided by 8, and that is going to give me a lovely 0.375. Let's say that's still not an answer. Take it again. Change it into a what? A percent. So you can multiply by 100, right? Or move the decimals to make swoopies to the right. So 1 swoopy, 2 swoopies. 37.5%. And sometimes they like to round to give you an average of 38%. Right? So these are all different answers to the exact same answer. Winner, winner, chicken dinner. Number 2. Okay, another probability and statistics problem, as I was asked to do for today. I love these problems. You guys are like, she's too much for me. So if a bag of balloons consists of 47 white balloons, 5 yellow balloons, and 10 black balloons, what is the likelihood a balloon chosen at random from the bag will be black? I don't know. I can see you guys like throwing your arms up in the air and waving it like you just don't care and saying, I don't know. You answer the question. It's not that bad, I promise. I know I always make promises like these, and you guys are always like, please stop. So, what do we have? Start with what we know. We know 47 white, we know 5 yellow, and we know 10 black. Well, on things like this, what's the first thing that you guys always end up doing before I tell you to do the problem? You guys always do this and it never fails. You guys always give me the total. So how many total balloons do I currently have? And if my math did me correctly, we should have 62 balloons, right? So now that we have our 62 balloons, what is the question asking us? It's asking us what the probability is that we do what? We select a black balloon at random. So we go back to the fraction that we used the last time, and remember it's going to be the part that we're looking for, looking or solving for, right? Over the total. All right, here we go. So what are we looking for? We are looking for the black balloon over the total amount of balloons that we have. So let's go ahead and put in what we know. We know that we have 10 black balloons, 10 out of 62 in total. That is not an answer, so we have to change its form. So all of these are in percentages, so let's put it into a decimal. 10 divided by 62, that gives us 0.16. Take that into a percent, multiplied by 100, or 2 swoopies, and that will give us 16%. Ooh, I love the answers. You guys are correct today. 8. 16%, winner, winner, chicken dinner. Woohoo! Okay, so you guys are probably like, okay, this is really simple. Like, challenge us. Okay, well, it's not much of a challenge, but it's a different type of question. If a bag of balloons consisted of the exact same amount of balloons, now let's change the question a little bit. What if we pulled a black balloon and then a yellow balloon? Will it still be one fraction? Will it still be one fraction? No, it needs to be how many fractions? Two of them. We need two fractions. We're pulling two balloons, so we need two fractions, right? So our first balloon times our second balloon. So now we go, what do we have? What are we looking for? So this is what we start with. And then the second one goes to what we have now. This will matter because sometimes it changes, right? So we go, okay, well, the color that we're looking for in both cases happen to be first is black, second is yellow. Does the total here change? Does the total here change? You should be yelling no. I should hear you all the way in New York saying no, it does not. The total will not change. How do we know? They didn't tell us to change it. They didn't say to keep it. They didn't say put it back. They didn't say anything. So if I pass you my pencil, are you just going to keep it? No, you're naturally going to give it back to me, right? So what's going to happen here is they didn't say to give it back, they didn't say to keep it, so you naturally have to return the item. So every time you now pull, it returns to the original, let's just say the original. Just returns to the original. So we go and we ask ourselves, well, how many black balloons are there? There are 10 of them. And how many yellow balloons are there? There are 5 yellow balloons. 62 is our denominator in both cases, right? Because we didn't change it. Which now we can go ahead and multiply. Now, when we're multiplying, you want to make sure you're multiplying your numerator to your numerator and your denominator to your denominator. And before you ask the question, do I have to reduce? Yes, you do. But that's the situation based on your exam that you're taking. Sometimes 50 over 3,844 will be an answer. Sometimes it won't, right? So you want to make sure that you're glancing at your answer choices. If this is an answer choice, then you want to reduce and move forward, right? So you can, like I always remind you guys, you can reduce before, right? You can reduce before. So I know 10 and 62 are divisible by 2. So I'm not going to make this too complicated. I'm going to divide both of them by 2. And I'm going to get 5 over 31. Now when I multiply my 5 to 5 and 31 by 62, instead I'm going to get 25 over 1922. 1,922. Okay, now here's a quick trick. Let's say you don't trust yourself with your math, which some of us don't. I still have trust issues sometimes. What I want you to do is go ahead and take 22 divided by 1,922, so 25 divided by 1922, and put that decimal on your paper. We get 0.013. Now I want you to take 50 and divide that by 3844. And what do you get? 0.013. If for whatever reason, when you're doing your math and you are reducing your fractions, that your decimals do not match up, let me tell you right now, something went wrong. That is a ruh-oh situation and you want to fix it, right? So that just means that maybe somewhere you didn't divide properly or you just forgot a number. So if your decimals don't line up with your fractions and they're not the same decimals, then you want to check your math, right? So that's a quick way of always knowing what's right or wrong. Another quick thing is, let's say that you are here at the 50 over 3,844. And you go, well, I don't know how to reduce that. Your mind has gone absolutely blank and you're just like, I don't know what to do. What do I do? Help me, please. Put it into decimal form. When you put it into decimal form, then one of your answers will also match the exact same decimal form. That is the trick tip here, right? So don't panic. There's always a way out. All right, so now that I can see the comments, go ahead and if you have a question, drop it in the chat. I will be more than happy to help. So here's another question. Same situation, right? But instead now we want to take a black balloon and another black balloon. So I would like to ask, did we by chance keep the balloon? So will the total, for whatever reason, change in this case? Will the total change? Well, let's start with, it's a black balloon and another black balloon. Okay, the total has not changed for the total amount of balloons that we have. We have 62 balloons in total, right? And remember, the number that goes on top is the color that we are selecting, and the number at the bottom is the total amount that we have at that moment in time. All right, so the first fraction will always tell us what we start with. Okay, so let's start with what we start with. How many black balloons do I have? 10. How many balloons in total do I have? 62. That's it, I'm done, right? Now I'm gonna move on to the next fraction. The next fraction tells me that I also would like a black balloon, okay? So now we ask ourselves the question, does my number change? What do I have now? Did they tell you to keep the first black balloon that you chose at random? Did they tell you to keep it? No, 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 they did not. So what do we know? We know that we still have 10 black balloons, which means that we still have 62 total balloons, which means that we will multiply straight to get our answer. 10 times 10 is 100, and 62 times 62 is 3,844. Now remember earlier, we reduced our fractions, right? And we had 5 over 31. So we're going to do 5 over 31 both times. And we got this by dividing the numerator and the denominator of both fractions by 2. So all we're doing now is reducing fractions. Now when I do 5 times 5, I will get 25, and 31 times 31 will give me 961. So either or either of these fractions will be your answer. So they didn't say to put the balloon back, so we have to keep it. I meant they didn't say put it back, so we have to return it. I didn't mean what I said first. They didn't say put it back. They didn't say to keep it, so we always return it. If they don't tell you what to do, you always go back to the original. One more time. If they don't tell you what to do, you always go back to the original. So if I gave you my pencil and I didn't tell you to keep it, but I didn't tell you to give it back, what do you naturally do? You return the item, right? So what I'm going to do is I'm going to put my hand in. Now, what is the probability? What are the possibility of me selecting a black balloon? So nothing has been done to the bag of balloons, right? So what are the chances of me pulling a black balloon? That's here. Well, I have 10 black balloons out of 62 in total. Now I take that black balloon out, but they didn't tell me to keep it, so I put it back. Right? They didn't say anything, so I put the balloon back. Now I'm going to do it again. I'm putting my hand back in the bag, and I'm going, okay, what are my chances of getting a black balloon? I grab a black balloon. My chances are 10 balloons out of 62. It's a what are the chances of me pulling it option not after I pull it, what do I have? Okay, I hope that helps out a little bit more. Now, I keep asking you guys, well, what if they didn't say anything? But what if they did say something? What if they said to pull a black balloon and without replacement, another black balloon? Now they told us what to do with our balloon. Here we go. I still am going to have two fractions. And I know that right now it's black and black. Black, black. Okay, now let's start with what I have. What do I currently have? I currently have 10 black balloons and 62 in total, right? Our total is the bottom. But if I put my hand in my bag and I pull a black balloon out and I keep it, because it says without replacing it, so I get to keep it, put it behind my back, how many black balloons do I now have in the bag? How many black balloons do I now have in total? So I have one less black balloon in the bag, 9, and one less total, 61. So now we're going to multiply those straight across. 90 over, oh, that's a number I forgot to do. 61 times 62. Oops, 61 times 62. 3,782. And if we reduce it, I will get 5 over 31 times 9 over 61 to give me 45 over 1,891. I use large numbers on purpose here because you guys get so comfortable with those really tiny numbers that when you see big numbers like this, you panic, right? I can see the panic in some of you. So this is what happens, right? So now they told us to do something with it, so now things change, right? So it's just making sure you understand the question. Hopefully that helps. I know I saw a lot of please help, I'm confused, right? But I hope this cleared it up a little bit because now I actually did a problem to where it told you to keep it, right? So now you can see what will happen if they tell you to keep it. And they can say things along the lines of without replacement, if it falls out the bag. So like say you're running and something falls out the bag. They didn't say you picked it up, so it's just out in no man's land, right? So you just want to make sure that you're understanding what the question is saying and what you have to do in order to be successful in it, right? Number 3, I know, another probability and statistics problems. I'm full of them today. Okay, so what does it say? It says Auntie Pryia. I know, I've been missing my nieces and nephews, so I went on a question just for them. So Auntie Pryia decided to take her nieces and nephews to visit Central Park. And she has 3 nieces and 4 nephews. And they want to know, here's the question. How many different ways can Auntie Pryia seat the children in the car seats? Well, I forgot to put how many car seats there are. In the 7 car seats. Okay, 7 children, 7 car seats. In the previous questions, yes, you always multiply. So 7 children, 7 car seats. What are you guys figuring out here? Is it 7 times 7? Is it what? What is it? What are you guys thinking? So this is one of those situations where you have to ask yourself some questions. Does order matter? Right? And if I had to draw out the situation, let's draw Auntie Pryia. I'm not that much taller than the children, so I'm going to be that person, and we're just going to make the children a little bit smaller. So there's 1, 2, 3, 4, 5, 6, and 7. Okay, here's answer Pryia. Here's our lovely, we've got to be driving a van or a bus at this point, right? So here's our motorized vehicle, and it's got the open door. There's our open door, right? So now I have to put these children into that vehicle. Yes, this is something you will definitely see on the GKT. So what happens? So I'm going to draw my car seats off to the side. 1, 2, 3, 4, 5, 6, 7. So there are my car seats. Now, why am I taking it slow? Because I want to make sure that you get this. Are you ready? So for the first car seat, I'm going to circle it. Here's car seat 1. How many children can go in the first car seat? We know only one child can fit in the car seat, but how many children can I grab from to go into that car seat? How many children have the potential to sit in seat 1? 7. You should say 7, because I'm not looking at my children, my nieces and nephews. I'm not looking at the children. I'm just looking at the amount. So right now they're kind of like playing and whatever. I have 7 kids to grab from. So I'm going to grab a kid. I'm going to put, so right now we have 7 kids have the potential to sit in seat 1. So if I put a child in seat 1, so now let's say this guy's gone. I have how many children left to grab from? How many children can now be selected to sit in the second seat? 6. Now we're going to keep going with this, and I'm going to go to the third seat. We have one less person, and we're going to get 5, 4, 3, 2, 1. Ooh, I like what I see in the chat. I like things like this. Yes, so what's happening right now is we have 7 times 6 times 5 times 4 times 3 times 2 times 1. But I didn't put the multiplication sign, because I wanted you to see this before I did all of that, right? So now when we multiply 6, 5, 7, 6, 5, 4, 3, 2, 1, what is the lovely number that we get? 5,040. Okay, so here's the thing. Let's say that you don't see it like this, right? And you want something a little bit more quote unquote concrete to stand on. There are permutations and combinations, right? And I know everyone's probably heard this and you're just going, those things just confuse me. Yes, they do, but let's talk about them. So our answer here is 5,040, but I'm going to show you another way to solve the problem. So combinations says that order doesn't matter. What do I mean by that? It means that it doesn't matter in which way the children go into the car seat or however they get placed. Yes, but no, because what happens is once we put a child in a seat, we cannot have them sit in 2 seats at the same time. I cannot sit in the seat that I am in and sit in the seat next to me at the same time. So in this case, order matters. Now, what do we use when order matters? We use a permutation. And permutations normally look like this. A little n, a big P, and a little r. And people go, what does that even mean? And this is order matters. What does it mean? It means that n is the total number of items. So number of items. And does anybody know what r is? It's the number being selected. So here we have what? We have 7 nieces and nephews total. So we have 7 total. So 7 is our n. And we're selecting all 7 children. We're not selecting some of the children, we're selecting all of the children. So R is also 7. Okay, now some of you may be like, how do you do this? Well, let's go ahead and put it into that formula that you're supposed to know that goes with that little n, big P, little r. That formula is n factorial all over n minus k or r, right? So people use those interchangeably, factorial. So you can have a k and you can have an r, right? It's interchangeable. Don't let it bother you. So now we go, okay, well, what do I know? I know that 7 is my n. So I'm going to plug in 7 for my n and 7 for my r, and I'm going to do the math. So remember, factorial means you start with that number and you go all the way down to 1. So we have 7 times 6 times 5 times 4 times 3 times 2 times 1. Boom. Now in the denominator, what do we have? 7 minus 7. That's 0. Keep your factorial. Does anyone by chance know what 0 factorial is? If it's 0, then we have a problem, right? This becomes something that we can't solve. So it's if you know, you do, and if you don't, now you do. 0 factorial is equal to 1. So that's great, because now all we have to do is the same thing that we did the last time. 7, 6, 5, 4, 3, 2, 1. Multiply them all together, and you get a total of 5,040. Right? So in this case, it still worked. So let's just say that I didn't want to select all the children to go to Central Park with me. Let's say that my van only has, I don't know, how many seats does a van have? Like 5? 5 seats. So let's go ahead and change this now to selecting only 5 of the children. Yes, we will have 5 very sad children, but we got to do it. We got to do it for the purpose of math, right? So let's keep the 7 children in total, but now we're only taking 5 of them with us. So I'm going to have 7 minus 5 factorial. That will be 7 times, well, before I do that, hold on. 7 factorial all over 7 minus 5 will give me 2 factorial. So now what I'm going to do is kind of one of two things. I can write this in one of two ways. I can do 7, 6, 5, 4, 3, 2, 1. All over 2 times 1. Or I can write 7 times 6 times 5 times 4 times 3 times 2 factorial over 2 factorial. So let's say it was 5 factorial. I would write 7, 6, 5 factorial. So that helps because, as you can see, the 2 times 1 in both cases technically work to 1. They cancel each other out, right? So then I'm just left with 7, 6, 5, 4, 3. And if you do 7 times 6 times 5 times 4 times 3 times 2, that's not right. Oh yeah, it is right. No, wait. Hold on, not times 2. 7 times 6 times 5 times 4 times 3. 2,520. Not times 2, just times 3. That's your new answer. So now instead of having 5,040 different ways to do it, I only have 2,520 different ways to do it, right? So it's always about knowing your question. Okay, here we go. I know this is not an A, B, C, D kind of answer. It's a let's do part A, B, C, D to F kind of thing. So these are going to be the parts that we're going to work through. So the principal wants to organize the data collected. And the data collected are these numbers. And those numbers are the 4th grade end of class math exams, right? So let's start with what is it to be a mean. We're going to go through mean, median, mode, range, mid-range, and standard deviation. We're going to do all of them tonight. I know I'm crazy tonight when it comes to probability and statistics, and I'm just ready to do it. Are you? So let's start with mean. So what does it mean to be mean? Not like physically mean, like, I'm really mean to you. I called you a poopy head or something. That's not what I'm looking for. What am I looking for? What is the definition of mean? Well, another word for mean is average, right? And when you take the average of something, what do you find yourself doing? You're taking the sum of the data and you're doing what? You're dividing it by the number of data you have. So we're going to ask ourselves, well, how many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now we need to add them all together. When we add them together, what do we get? The sum of all of these numbers is 688. And we're going to divide it by 10. So now that we have 688 divided by 10, let's go ahead and put that into a decimal form. I will get 68.8. So 68 and 8/10, if you wanted to get technical. And normally your answers will be in decimal form. You know, they really could be in any form they want because the test, they can do what they want, right? It could be in decimal form, it can be in fraction form, it can be in percentages, it can be however they want you to do it. But the average is the other way of saying mean. So you're simply going to sum the data up, which means add it all together and divide by the amount of data that you are provided with. And in this case, it is 10. All right, I promised you all the pieces, so that's mean. Let's talk about median. So who out there drives? And if you don't drive, what is the median? Just in case you forgot, it is that lovely thing in the middle of the road, right? That big solid concrete block, or normally filled with grass, sometimes trees. That is the median, and it is in the middle. So the median means middle. Okay, so we're looking for the middle number. Do I simply just do this? 15 and 32. They seem to be the middle numbers. Wham, bam, thank you, ma'am. Am I done? No way, Jose. If it was that easy, we could all do it. It would be so simple, right? But it's not. It's not as simple as we want it to be. What they want us to do is take the numbers and put them in order. So remember, they must be in order. And ascending order is the best. So you start with the smallest and you go to the largest, right? So that would be the best order to put them in because that is how they fall on the number line. So when I put them in order, I will have 15, 32, 57, 61, 69, 78, 85, 92, 99, and 100. And you want to make sure that you count them to make sure you have the same amount of numbers that you started with. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. All right, now we're going to find the number in the middle. And you can slash one at a time. When I have large numbers, I like to kind of do like 3 or 4 at a time, sometimes 2. It's really just up to you. Sometimes you get a little crazy. You don't want to do too many because you would really hate to slash off too many numbers. So here's the thing. Do I just list these numbers and say 69 and 78? Those are the middle numbers, and that is all I need to know. Is 69, 78 my answer here? No, not at all. It is not the number that we're looking for. We still have to find the middle of those numbers. So here's what happens. We have to find the middle of 69 and 78. We can do this one of two ways. We can do this the way that you guys were kind of taught to do it, which is take the average, yes, or we can write them out, right? And let me just show you the simpler way to do it. So let's say you forgot that you need to take the average of these numbers. So what you're doing now is writing out the numbers from 69 to 78, including the numbers. And now you're going to look for the middle number. Okay, so that didn't help because now we're left with 73 and 74. But what number's right in the middle of 73 and 74? 73.5. And you would definitely be able to do that if you had 6 and 7. You'd go, well, the number in the middle is 6.5, right? Because right in the middle of 6 and 7 is 6.5. So right in the middle of 73 and 74 is 73.5. But let's say you want to do it mathematically. Totally down for this math stuff, right? We're going to take the average. And to take the average, we're going to do 69 plus 78 and divide that by 2. We have two numbers. Our numbers are 69 and 78, and we get 73.5. It's amazing that you can do the same thing in multiple different ways. I know, right? Right, you know the deal. If you have questions, ask in the chat. Here we go. The mode. What does it mean to do the mode? Mode is the number we see the most. Do we have any number that occurs more than once? No. So we don't select 0 because 0 is still a number. We select there is no mode or NA or anything that does not actually give you a number because we do not have a mode. Everything occurs once, so we do not have a mode. But let's say I had two 15s, right? Then I would say 15 is the mode. But now let's say I have two 15s and let's do two 32s. And still all the other numbers, right? Well, now I can list my modes because I have two 15s and two 32s. So I'm going to say 15 and 32 are the mode because those are both numbers that are tied to be the most. And if for whatever reason there was three 15s, then I'd go back to just 15. You get the whole play the game thing here, right? So in the original problem, we have no mode. And in the problem I recreated with two 15s and two 32s, we're going to list the answer as 15 and 32. All right, here we go. The range. What is the range? What does it mean to take the range of something? The range is normally the distance, right? The distance between stuff. So what we're going to do here is we're going to have the range as the largest number, and we're going to subtract smallest number. So in this case, order does matter, right? Because you need to have your numbers in order to find the largest and the smallest. So we already know what the largest and the smallest are. We have 15 and 100, right? So we're going to do the range. And I really love writing the words to this because sometimes you guys don't realize that it is words to numbers. 100 minus 15, and my range is going to equal what? 85. And that's pretty easy, right? That's pretty straightforward, pretty simple. The range is just 85. It's the largest minus the smallest. But now I spiced it up a little bit. Now, instead of asking for the range, I'm asking for this thing called the mid-range. What is that? What is the mid-range? Can somebody tell me what the mid-range is? It's not a term that occurs often on the tests, but when it shows up, it's definitely something they want you to know. What is the mid-range? What does it sound like? It sounds a lot like the median and range, because it's like the middle range, it's like the mid-range, the median and range. So what did we do again when we had numbers in the middle? We had to add them up and divide them, because in order to figure this out, we have to now use the largest and the smallest and divide it by 2. So what's happening is we take the largest number, we're going to add the smallest number, and we're going to divide that by 2. So now we're going to have 100 plus 15 divided by 2. I'm going to have 115 on top divided by 2. And when we do 115 divided by 2, our answer is 57.5. So remember, the mid-range, the median range, is going to be the largest plus the smallest, and we want the middle number of the range. So the range are 2 numbers, and we have to divide the sum of them to get the middle of the range. So you have to figure out how far apart they are. There's 115, and we divide that by 2. So the middle of the range is 57.5. Okay, so for the example of standard deviation, we're not going to use all those numbers. That's 10 numbers and a lot of time, right? So instead, I came up with just 5 simple numbers. I put them in order for us, so it's nice and easy, right? So this right here are the numbers that we're going to use. That's it, just those 5 numbers. And there's 2 ways to actually look at standard deviation. Why do I say there are 2 ways to look at it? Because it's very important to know that you can do this one of 2 ways. And there are 2 simple radicals that go with this, right? It's 2 simple formulas, and it's just knowing how to do them. So the first formula that everyone knows is this formula. The sum of the data minus the total squared all over the number that there are minus 1. And then you have to know what all those things mean, right? Or there is, I know this one's going to look even crazier, but I promise you it's actually easier. The sum of x squared minus the sum x being squared, all divided by, n, all divided by n minus 1. Okay, Ms. Pryia, you have absolutely lost your mind. I know, thank you, I appreciate it. Let's start looking at the first guy. Then we're going to look at the second guy. We're going to name the second guy the blue guy, so we're going to do everything first in purple. So what were our numbers again? 2, 4, 6, 8, 10. 5 numbers, right? So what does that 5 represent? Remember, 5 is our n, so instead of writing it that way, I should write it n equals 5. Because we know that. So I'm going to rewrite our formula. The first formula that everybody knows is the sum of x minus the sum of x squared to n minus 1. Okay. That's what everybody knows. So what do I have to do here? Well, I have to come up with my items, right? So I'm going to start with the first part, which is the sum of x. So I'm going to total it all up and do what they tell me. And to do that part, I need to do 2 plus 4 plus 6 plus 8 plus 10, all divided by the amount that there is. Right? So when I total the top, I'll get 30 divided by 5 gives me 6. So right now we know that x bar is 6. Okay, 6, that's it, that's all we have. Then I have to do this part. X minus x bar. Well, in order to do that, I need to physically subtract them. So I'll have 2 minus 6, 4 minus 6, 6 minus 6, 8 minus 6, and 10 minus 6. And I'll get my new numbers. I'll write them in a different color so they're easier to see. My new numbers are -4, -2, 0, 2, and 4. Okay, that's great, right? And then I still need to do one more piece so I can plug it all in, because if not, then I'll have a lot of stuff to write out. It tells me that I need to do the sum of all of this, right? The sum of all of that squared. So let's do that over here to make it easier for ourselves so then we don't have to figure it out later. So x minus x bar squared. So now we're going to do x minus x bar squared, and we're going to get -4 squared, 16, -2 squared, 4, 0 squared, 0, 2 squared, 4, and 4 squared, 16. But remember they said they wanted the sum of it. So if you come down to the bottom, you can do the sum of x minus x bar squared and add up 16, 4, 0, 4, and 16 to get 40. Okay, so now that I've got all my pieces that I need, now we're simply going to put them all back into the formula, right? So I'm going to have 40 that we just came up with over 5 minus 1. Keep my radical, don't make that go anywhere until we're done. And 40 divided by 4 is 10. That is my answer. I know, there's like a lot that goes into it. A lot of you are like, this is overwhelming. How dare you do this problem? I know, I'm so sorry. But I'm about to teach you an easier way. I promise, 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 okay? Here we go. Here's the easier way, the second equation. The second equation may look crazier, right? But I promise you, it makes the world of difference. I know, like, how is that any simpler than what we just did? I promise it's simpler. Are you ready? Here we go. We're going to start with our x's. And what do we notice here? We need an x squared. We need the sum of x squared, right? And this guy is different. And we're going to talk about them. So we need the sum of x squared. Well, let's do it. We have 2, 4, 6, 8, and 10. X squared will be 4, 16, 36, 64, and 100, right? 2 squared is 4, 4 squared is 16, 6 squared is 36, 8 squared is 84, 10 squared is 100. All right. Now we need to do the sum of what we just did. The sum of x squared. Add 4, 16, 36, 64, and 100 together, and you get 220. That was a bad choice of color. Let me fix that. So we have the sum of x squared, and that's 220. Okay, doesn't seem so bad, right? Now, what else did we need? We needed that purple part, the sum of x and that being squared. Well, what's the sum of x? The sum of x is over here. The sum of x is the total of 2, 4, 6, 8, and 10, which is 30. So now we're going to take 30 and square it, which will give us the sum of x being squared, which is 90. Just kidding. It's, yeah, 90. No, 100, 900. Just kidding, 900. This is why I should probably write it out. 30 times 30 is 900? Yes, yes it is. Okay, and that's it. That's all we kind of really need. Now we just kind of have to plug it back in. I know, how dare I? Here we go. The sum of x squared is 220. And now we're going to subtract the sum of x being squared, 900. Divide that by n, which is 5. And divide all of that by 5 minus 1. We will get 220 minus 180 divided by 5. I meant divided by 4, because 5 minus 1 is 4. Okay, so let's keep going. We're almost there. We have 220. 220 minus 180. 220 minus 180 is 40 divided by 4. Looks a lot familiar. 10. Our answer is 10. Our answer is 10, and it was faster than the last time. Our answer is radical 10, not just regular 10. It's radical 10, square root 10. It is the same as the last one. Look at this problem that we just did. And then look at this work that we did. So it's really up to you. Which one do you want to remember? Which one are you going to use? Right? I was taught both ways growing up, so I always kind of knew the other way to do it, which is the way that I did the second time. And then we have one more problem. Because I was late, I'm going to do the last problem with you guys. Solve the logarithmic function. I know, I told you that I had one problem outside of probability and stats today. So we look at the problem and we go, okay, well, I don't know what really to do here, so I'm going to do what I know best, and that's to move things from one side to the other that I can, right? So I'm going to start by dividing both sides by 7. Divide both sides by 7, and what do I get? Log base 5 times x plus 27 is equal to 2. All right, well, this now yields a property that you either know or you don't, and I'm going to write it out over here. And you have to know how to use it, because if you don't know how to use it, then there's no point of knowing it, right? It's just going to stare you in the face, or you're not going to know what to do with it. So now that I have this information, I can change it from a log form to an exponential form. By saying 5 to the second power is equal to x plus 27. Now, in order to solve, it's simply doing the math. 25 is equal to x plus 27. Subtract 27 on both sides. And x is equal to negative 2. Wham, bam, thank you, ma'am. Boom! We made it. Again, I'd like to apologize for being late today. Today, technology said no, thank you. A big thanks to everyone out there for always showing up and doing math with me. I appreciate doing the math with all of you. As you know, the Learning Liaison has more to offer than just what we do on Math Wednesdays. We have online tutoring and our lovely booth camps. So I can't wait to see some of you face to face. See you soon. Bye, everyone. Thanks again.